So, here's the last of the comic strips na nakita ko. So, basahin nyo, tapos, tignan nyo, tama na ba siya, o hindi pa rin, o katulad kayo nung girl na dinudugo na yung ilong kakabasa doon sa sinabi ng aircon. Let's look at the third part of our video series, thermochemical equations. Dito matututunan natin kung paano ba natin nare-represent yung energy changes using just simple chemical equations. At titingnan din natin kung paano tayo mag-drawing ng diagrams illustrating how these energy changes occur. So kapag binigyan tayo ng isang process, for example, melting of ice, kailangan nating i-consider yung ilang mga bagay bago tayo makapagsulat ng tamang thermochemical equation and enthalpy diagram. First of all, hindi ibig sabihin na walang chemical reaction na nangyari, wala ng thermochemistry na pwedeng pag-aralan. So for instance, sa melting of ice, ang transformation na ito ay nangangailangan pa rin ng transfer of energy from one point to another so that the transformation would occur. At kapag sinusulat natin yung kanyang equation, doon natin makikita kung paano nagpa-play ng part itong transfer of energy na ito. Some concepts to consider is this a constant pressure process? Kasi kung ito ay constant pressure process, then more or less we can equate the quantity that we discussed earlier, which is change in enthalpy, to our change in internal energy. Didefine din natin dapat kung alin ang system, alin ang surroundings, because after we define those things, we will probably be having an easier time defining whether the process is exothermic or endothermic. So, unang-una sa lahat, kailangan muna nating ipakita yung tamang thermochemical equation tulad nung nakikita natin sa taas. Melting of ice, obviously, wala na tayong ibang reactant sa makita kundi H2O. If we write our chemical equation just like this, wala tayong masyadong nakikitang description kung ano ba yung nangyayari na process. Alam lang natin na nagme-melt yung ice kasi nilagay ko dito. How do we show that in our thermochemical equation? So the first thing that you have to do, it's very, very important in thermochemistry to write the states of your reactants and your product. Bakit importante na ilalagay natin yung states ng ating reactants at products? Yun ay dahil alam natin na even though there is no chemical change happening, energy can still be transferred and can be exhibited in a change of phase or change in state. Tulad nitong melting of ice. Nung nilagyan na natin siya nung ating states enclosed in parentheses, we can actually understand better, kahit wala na yung label na melting of ice, we can understand better what is happening in our system. Ngayon, makikita natin na since melting tayo, we know that our delta H would be positive. Why? Because to break the bonds of your solid and turn them into fluid molecules in a liquid, then you need to input energy in your system. And it turns out, our delta H would be plus 6.01 kilojoules per mole. Itong part na to ng ating thermochemical equation is very, very important, especially if you're going to describe the amount of energy transferred quantitatively. Another way of writing it is by treating the heat or the amount of heat as a part of our reactants or our products. In this case, we can also write this thermochemical equation as H2O solid plus 6.01 kilojoules per mole, and the product is our H2O liquid. We can also represent the process as an enthalpy diagram. Parang yung energy diagrams na diniscuss natin in previous lessons in your previous years pa. Tulad ito, magdodrawing tayo ng energy diagram by drawing an arrow going from the bottom to the top, representing an increase in energy, in this case, increase in enthalpy, At i-represent lang natin yung products and reactants natin, making sure that yung kanilang position in our enthalpy diagram represents to the amount of energy that they had before and after the reaction. So for example, yung H2O natin na solid or ice ay nasa baba because it is the one which is lower in energy. While our H2O liquid water, is at the top to represent that it has a higher energy. At yung difference from this level to this level would correspond to 6.01 kilojoules per mole. And that is the heat absorbed by the system from the surroundings. So let's try another example. We have the burning of methane or CH4. Ang unang-una natin kailangang malaman ay kung ano yung ating balanced chemical equation bago tayo makapagbuo ng ating thermochemical equation. Just like the previous example, you have to know whether this is a constant pressure process. Yes. What is the system? That is your reactants. The surroundings are everything else. And we know that CH4 burning is an exothermic process. So, i-review lang natin. When you have burning or combustion reactions, you add oxygen to your reactants, and usually, if it's a hydrocarbon or a carbon with a hydrogen or hydrogens burning, then your products would be carbon dioxide and water. So here we have the balanced chemical equation, and completing our thermochemical equation is our value for delta H, which is negative 890.4 kilojoules per mole. Kung isusulat naman natin yung ating enthalpy diagram, again, the species involved in the reaction, which is lower in energy, must be found at the lower level to represent the low energy, and yung higher energy species should be at the top. In this case, since exothermic ito, mas mataas ang energy ng ating mga reactants kesa sa products. So, methane and oxygen would be here, and our products, carbon dioxide and water, would be here. The distance between the two would represent the negative 890.4 kilojoules per mole heat which is released to the surroundings. So the following are guidelines that will be useful when considering or writing thermochemical equations. Let's look at the first one. Always specify the physical states of reactants and products because they help determine the actual enthalpy changes. Kasi tulad nga nung sinabi natin do sa ating unang example, yung mismong act or yung mismong process ng pag-change from solid to liquid, liquid to gas, at iba pang mga physical transformations involve heat or energy changes. For example, balikan natin si combustion of methane. So, meron akong dalawang equations dito. Same reactants, same yung mga mavo-form na molecules, pero kung titingnan natin yung ating delta H, for the first one, it's negative 802.4. And for the second one, it's negative 890.4. Both are in kilojoules per mole. Bakit magkaiba? Kung mabilis kayo maghanap ng mga find the difference, you will see that the state of my water in the first one is different from the state of my water in the second one. So ngayon, titingnan natin. May sense ba na mas maliit yung energy released dito sa first reaction kaysa dun sa energy released in the second reaction? Pero teka lang, I have to stop myself kasi baka nawindang-windang na naman kayo. Parang di yata marunong mag-math si ma'am. Ma'am, mas maliit yung negative 802.4 sa negative 890.4. Tawa tayo. Tandaan natin na ang ating negative at positive in our thermochemistry just denotes the direction of our energy transfer. Ibig sabihin, yung negative na yan, ang sinasabi niyan, palabas yung ating heat from the system. Kaya naman, kapag dinidescribe natin siya, mas maliit yung lumabas na heat sa ating system in the first equation compared to the second equation because the value for delta H is less negative in the first one compared to the second one. Gets ba? Okay, ulitin ko. Mas maliit ang energy na nilabas nito kasi less negative siya compared to this one. Okay, balik tayo. May sense ba na mas maliit ang energy na nilabas nito kesa dito? Ano sa tingin nyo? So, i-analyze natin. Kung meron akong H2O gas na magiging H2O liquid, anong kailangan kong gawin sa energy ng aking gas para maging liquid siya? Do I add heat? Or do I remove heat? So, dito sa example natin, H2O gas, para maging H2O liquid, anong gagawin natin? You remove heat. At yung removal of heat na yan yung magko-correspond doon sa difference between the delta H's ng ating first at ng ating second equation. So remember, when you're dealing with thermochemical equations, mortal sin kapag hindi nakalagay ang physical states. How about this one? I-try nating i-deduce kung ano yung second guideline. Meron ako ditong same equation, yung aking combustion of CH4. Meron akong specific na delta H for that equation or reaction. And I have another equation here. At hindi natin alam kung ano yung kanyang delta H. Look at the relationship between the first and the second equation. Tapos, subukan nating i-predict kung ano yung delta H natin. Ano ba ang nangyari or ano ang difference ng first at second equation? The second equation is just the first equation multiplied by 2. Ngayon, kung ipapahula ko sa inyo kung ano yung delta H ng second equation, what do you think would happen to it? So kung ang hula nyo ay magdodoble yung ating energy released, you are correct. Because enthalpy is an extensive property. So when multiplying an equation by a certain factor, in this example, we multiplied our first equation by 2, then you also multiply this H value by 2, which is the same factor that we used to multiply our thermochemical equations. How about this one? Ano ang nangyari sa second equation at anong relationship niya dun sa first equation? So, kung titingnan natin, the second equation is just the inverse or the reverse of the first equation. So, kung ipapahula ko sa inyo kung ano ang mangyayari sa delta H for the second equation, what do you think will happen? So, kung ang hula nyo ay babaliktad ang sign, then you are correct. Because reversing an equation changes the sign but not the magnitude of delta H. So let's try solving for this problem. Given a thermochemical equation for photosynthesis, yung equation natin ay nakalagay dito, and this is the delta H for our equation as written. Calculate the solar energy required to produce 75.0 grams of C6H12O6. So, ngayon, a good rule of thumb when you're lost kung anong gagawin nyo is always look at what you want for the final units and then look at your given. So, in this case, since solar energy ang hinahanap ko, malamang ang unit ko ay joules. Or, in this case, kilojoules tayo. Kasi yung delta H natin dun sa problem ay in kilojoules na rin. So, you have kilojoules. And our given is 75.0 grams of C6H12O6. Convert that to moles. Kasi if you don't know what to do, convert everything to moles. Kasi malay nyo, dun kayo aha moment. So, 1 mole C6H12O6. The molar mass of C6H12O6 is 180.2 grams. So, when you calculate for that, you will get, let me check, 0.416 moles of C6H12O6. So, anong next natin gagawin? So, makikita nyo, sinulat ko ulit yung equation. Bakit? Para makabuo ako ng 1 mole of my product, 1 mole of sugar as a product, by this reaction, kailangan ko daw ng 2803 kilojoules per mole of solar energy. That's 1 mole of sugar. Kaya lang, sabi dun sa sinolve natin kanina, I only want 0.416 moles of sugar. So, anong gagawin natin? Para maging 0.416 moles of sugar yung mapoproduce ko, I have to multiply this one by 0.416. But if I do that, I have to multiply everything in the equation by 0.416 so that I would fulfill the law of mass balance. So, kapag ginawa ko yun, multiply this by 0.416. At according to our guidelines that we discussed a while ago, if I multiply my thermochemical equation by any factor, I should also multiply my delta H by the same factor. Which means, kung kanina I need 2803 kilojoules per mole of energy to get 1 mole of sugar, I now need 1.17 times 10 to the 3 kilojoules of solar energy. Try nyo naman ito. The major source of aluminum in the world is bauxite, mostly aluminum oxide. Its thermal decomposition can be represented by the equation given below. If aluminum is produced this way, how many grams of aluminum can form when 1.000 times 10 to the 3 kilojoules of heat is transferred? Take note of the units when you are performing your calculations.